In the automotive industry, OEMs do not approve coatings solely based on laboratory performance. Instead, they define strict process windows and assess robustness and risk to ensure long-term appearance and durability across full-scale production. Understanding these principles is critical for RD&I engineers responsible for translating formulation excellence into production-ready systems. Process windows are defined ranges of application and curing parameters within which a coating system is guaranteed to meet OEM specifications. This includes film thickness (DFT), solvent release and evaporation profiles, rheology, spray parameters, flash-off duration, and bake temperature/time combinations. A coating formulated to perform optimally only at a single nominal condition is considered fragile. OEMs require formulations that maintain performance across the entire allowed range. Robustness assessment is performed through controlled experiments and statistical design of experiments (DO) approaches. Key variables such as ambient temperature, relative humidity, film build, solvent composition, spray application settings, and oven thermal gradients are systematically varied to determine the limits of acceptable performance. Parameters outside these limits indicate potential production risk and may trigger formulation adjustments, process controls, or additional operator training. Risk management at the OEM level includes both pre-production and in-line evaluation. Pre-production risk involves predicting sensitivity to environmental and process variability and identifying potential defect mechanisms such as sagging, solvent popping, orange peel, or shade variation. In-line risk monitoring includes sampling, coating thickness measurements, gloss and appearance checks, and defect trend analysis. Coating failures in production have high cost implications, so understanding and mitigating these risks is a core RD&I responsibility. From an RD&I perspective, these evaluations dictate formulation and process strategy. Engineers must ensure that solvent systems, resin chemistries, rheology modifiers, and curing kinetics produce coatings capable of withstanding realistic production fluctuations. Laboratory tests must mimic full vehicle geometries, complex airflow, and thermal mass variations to accurately assess robustness. Approval strategies by OEMs are therefore system-centric. Individual layers are tested for compatibility, but the coating stack, primer, base coat, and clear coat, is validated as an integrated system. Performance criteria include adhesion, corrosion resistance, stone chip resistance, optical uniformity, and long-term weathering stability. Only coatings that meet all criteria across the defined process window are approved for production. In summary, OEM validation, process windows, and risk management form the backbone of automotive coating approval. RD&I engineers must design robust formulations, simulate production variability, and understand sensitivity to environmental and process factors to minimize defect risk and ensure long-term system performance. If you have technical questions related to OEM process windows, robustness assessment, risk mitigation, or system-level approval strategies, share them in the comments for discussion in future episodes.